vectors. So if you are a student of, what is it, geometry, I think. If you've had geometry, then you know about Cartesian coordinates and stuff like that. And when I draw this, oops, let's not do that. Let's do white instead. And if I draw this,
and you're using your finger, drawing your iPad, and then you're sharing.
well, I'm using a little pen, but yeah,
okay,
I'm on my iPad, and then I'm sharing the screen with the Air Server, which is what do you use the other one? What's it called? For casting your iPad to the screen?
Yeah, it's here someplace. Yeah.
Anyway.
Reflector.
Reflector, thank you.
Reflector, yeah. So you could use Reflector or this. Anyways, so when I draw this, people are like, oh yeah, that's a Cartesian graph, whatever you want to call it. And they're all familiar with the concept that this is
that's a
plus...
D-pad.
Sir?
That's a D-pad. Nintendo D-pad.
No, it's not. But yes, Mr. Joke. So you're all familiar with this concept that in the Cartesian coordinate system, plus y goes up, minus y goes down, plus x is to the right, and minus x is to the left. However, and that 0, 0 is in the center, right here.
You got to do your best John Madden voice when you're doing this. It's like you got the telestrator up. I love it.
Okay. So, I don't think I could do that. That's why I'm laughing. Anyways, when you get into the graphics world, however, you got to adjust your viewpoint, and your viewpoint now comes in, and it looks more like this. Yes, the system continues off above and to the left, but most people, when they get into graphics, this is what you're presented with, where this right here is now, the upper left is 0, 0, and y is going down is now plus. So whereas in Cartesian coordinates, going down was negative, going down is plus for graphics, and going to the right is still plus for x. So I only want to point this out because as we proceed, people will look at this, and if they're thinking in a Cartesian point of view, then when I start putting the y's in different signs, then they'll be confused. So remember that plus is going down. So the next thing that we need to understand, I kind of lost my train of thought there for just a minute, is, why don't we just do an example? So we want to create a turret, and we're going to have the good guy over here, and we are going to have the bad guy over here. And then we want to fire a bullet at this guy. But to do that, what we need to do is we need to do some math. We need to do some vector math. So the first thing we need to do is figure out how to point or to create a vector that will give us, will point in the direction of our bad guy. So this red arrow that I'm drawing here is the vector. Now, to get a vector, basically what you do is you take the position of, let's say, object A and object B, got a little more clear, and we'll say that the position of our guy over here is 10, 10, and our bad guy is 20, 10, so it's 10 more pixels to the right. What we'll do to get the red vector, this thing right here, is we'll say B, and this little line that I drew over that is something you might be familiar from school. When you put a line over it, what it means is it's a vector, B minus A, which comes out to 20 minus 10 and 10, minus 10. And these little brackets that I'm showing are just shorthand notation for a vector. So what we get is getting a little crowded here, but what we would get is, let me just draw it again real quick. And let's do this.
Need a scale feature.
Yeah, I try to have a little bit of everything on here. Well, I did this a few times while I was testing it to see how the talk would go. So what we get for the red arrow, our red vector, is going to be -10, 0. That's what that ends up being. Given that, we can do a number of things. We can calculate what the angle is by doing a little bit of math. We can turn this into what is called a unit vector, and then scale it to get a velocity vector. So these are all the kinds of things that we need to do when we are doing turrets. So first of all, what is a unit vector? A unit vector is a vector whose length is 1. It's a special kind of vector that is always a length of 1, and what that allows us to do, having a unit vector, is to calculate things like, let's say we know that the vector points off to the right, and we want to move an object 20 pixels in the direction that the vector is pointing. Well, what we would do, or 20 units, forget about pixels, just 20 units. What we would do is we would make sure that our vector was a unit vector and simply multiply it by 20 and add it to the current position of the object we wanted to move. So I'm gonna do that on the screen here and show you what I mean. First of all, I'm going to show you what a unit vector of this one is here, right here. The unit vector equivalent of this one is -1, 0. Now I won't show you the math to convert a vector into a unit vector because I have a math library to do that of my own. But the point is if you look at this vector and you're at all familiar with vector mathematics, you'll easily see that the length of this vector right here is 1, which is very important. So now let's say that I have an object right here that I'm just going to make it up. It's at 1525. And I want to move it in the direction of our vector, -1, 0, 22 units. So the way I would do that is I would say 22 times -1, 0 plus 1525. And I hope that hopefully people can read this. I'm doing kind of a cruddy job of keeping these things on the screen. So what that comes out to be is the equivalent of -22, 0 plus 1525, which then comes out to the final -725. So again, what we wanted to do is we have an object here, right there, which is at this initial position. We have a vector here that points in some direction. In this case, it points to the right. -x is pointing to the right, and 0 means it's not pointing up or down. So it's a horizontal vector pointing directly to the right. Then using this to encode the direction that we want to move our object in, we want to move it by 22 units of these. And so what we do is we simply multiply this, I'm waving at the screen, multiply this by 22, add it to this, and then we get the end result that this moves over. Well, I drew a let's draw it exactly to the right. At the end of the day, that operation would move this guy over here by 22 units, whatever that might be, in the virtual space. So what does this have to do with turrets? When we have a turret, things we have to do when we have a turret. We have to figure out what direction we want to fire in, so we got a vector for the direction. Then when we have the projectile, and we want to move it at a certain velocity, we have to calculate another vector for the velocity. And that's pretty much it. So given